Hello there, we have another screencast of the least square method, this time with a coasting stop of a container vessel. Say we have a time measurement and a speed measurement in knots and time is in minutes. And we got the following measurements. At time 0 the container vessel was doing a 28 knots. After 1 minute the speed dropped to 24. 2 minutes it was at 20 knots. After 3 minutes it was 17.3. 5 minutes it was at 13.3. After 7 minutes it was at 10.5. 12 minutes it was at 6.8. And 40 minutes it was at 6.0. Well, the container vessel in this case has a length of 295 meters and a displacement of approximately 65,000 tons. Well, that's not so important. What we see in the graph is that if we take a picture of it, I'll probably do it over here because I need a space to the right, that the speed drop looks something like this. If you look in pilot charts. So here I have the time, I have the speed over here, and here it started with 28 knots and it decreases. This could be something like the speed is a constant times a minus k times t. So it could be something exponential. You have a good look at the pilot chart because sometimes when you give half a stern, maybe a straight line is a better fit. But in this case, let's go for the exponential function. So here we say the exponential function here is y equals c times e minus kt. Say y is the speed. That's better. I'm always happy with a zero measurement because here we can say 28 equals c times e to the power of 0. So we have immediately a new formula with here a 28. That makes life a little bit easier. Well, you put in the other numbers. 24 equals 28 times a minus k, and we have a time of 1 minute. 20 knots equals 28 times a minus k, 2 minutes. 17.3 is 28 times. Okay, this will be 3 minutes. Well, and so on and so on. You can figure it out yourself. Well, what we do now is we divide both sides by 28. So we get something like here 0.857 equals e minus 1 k, and this would be 0.714 equals e minus 2k, and here is 0.618 equals e minus 3k, etc, etc. Next step is take the ln left and right, because the k is captured by the e power. To get rid of that, you say, oh, I do the ln of 0.857 equals the ln of a minus k equals minus k. Well, and the ln of 0.857 is something like minus 0.1542 equals minus k. Next one would be something like 0.3365 equals minus 2k. Another one, and then you can find that out yourself, 0.4815 equals minus 3k, etc, etc. So now you have to make your matrix. So this is your matrix A times x, and the x value is the k value, and I have the b over here. Now you can solve the x by the formula at times a inverted at times b, and I found myself a k value of 0.0944. Having found that, we have the formula of the graph, say the speed equals 28 times e minus 0.0977, no, 744 times t. And now you can find for every t, say, if you want to have, well, here 4, if you're looking for that number, it's not in the table, you can put in 4 over there and calculate v4 equals something. So that's the idea of finding the formula for this graph. We can give an accurate or accurate. We still don't know how accurate it is, but you can find measurements between the measurements you've done. Speaking about accuracy, you can say the error is something like b minus a times x, and the x value we just found, put it in as a matrix as well, and you can find the error. I found something like, I will not write them down all, but minus 0.057, and the second one was minus 0.142, and 0.189, etc., etc. Okay, thanks for watching.